You know, usually when we talk about getting a medical diagnosis, there's a very comforting expectation of precision.
Right, yeah. You want it to be clear-cut.
Exactly. It feels like engineering. You fall off your bike, your arm swells up, you go to the hospital, and the X-ray shows a very clear, jagged white line across your radius bone.
Like a structural schematic.
Yeah, the doctor points at the screen, and there it is. Broken, clean, binary, and just, indisputable.
Well, we crave that kind of visibility, right? I mean, our brains are hardwired to categorize the world into neat, observable boxes. A broken bone, a solid table, a distinct drop of rain.
But then you take a step into the realm of quantum mechanics, or you open a text on ancient Eastern philosophy, and suddenly that beautiful, precise X-ray machine just shatters.
Oh, completely. It just falls apart.
You find yourself looking at a diagnostic landscape of reality that is, to put it mildly, deeply murky.
It's the absolute definition of diagnostic muddy waters. Because the moment you zoom in close enough, those binary categories we rely on to navigate our daily lives, they completely dissolve.
Right. And that profound disorientation, that quiet sensation of looking at the seemingly solid world around you and wondering what is actually operating beneath the surface, is the engine driving our conversation today.
It's a huge topic.
It really is. So, welcome to the deep dive, everyone. We are unpacking a massive, incredibly dense stack of sources that you brought to the table. And when I say massive for you listening at home, this reading list spans the absolute extremes of human inquiry.
Yeah, we really covered the map on this one.
We've got, on one hand, these late-night Reddit threads of people trying to decode the mathematical mysteries of the quantum wave function, right? Plus transcripts from Google Talks by the theoretical physicist Carlo Rovelli and some very heavy academic papers on quantum field theory.
And then sitting right next to those physics papers, we have deep philosophical treatises on ancient Mahayana Buddhism.
Which is such a wild pivot.
I know, but it works.
Yeah.
We've got specific ontological breakdowns by a 3rd century mystic named Nāgārjuna and contemporary debates on the secularization of religion by philosophers like Evan Thompson.
Which brings us to the core mind-bending thesis of today's deep dive. When you put these two dramatically different stacks of sources side by side, a striking, almost perfect mirror emerges.
It really does. It's uncanny.
We are going to explore the parallel between the ancient Buddhist doctrine known as the Two Truths and the foundational quantum physics concept of wave-particle duality.
So to give you a roadmap of where we are heading today, we are going to look at how light and matter behave. In our everyday macroscopic world, light interacts with us as localized, distinct particles.
Like little bullets of light.
Right. And we will see how this maps directly to what Mahayana Buddhism calls conventional truth, which is basically the everyday world of tables, chairs, and distinct individual identities.
The stuff we can touch.
Exactly. But fundamentally, at the subatomic level, that exact same light exists as a smeared-out wave of absolute probability.
A wave of probability. It's just so hard to wrap your head around.
It is. And this mirrors the Buddhist concept of the ultimate truth. The realization that everything is empty of independent existence. It's entirely fluid and undivided.
The particle and the wave. The conventional and the ultimate. I mean, it sounds like a sci-fi crossover episode, but it is literally the cutting edge of modern physics shaking hands with the ancient edge of contemplation.
It's where the math meets the meditation.
Yeah. So to truly do this justice, I want to wade into the physics side of the equation first. We need to lay down the mechanical groundwork of just how strange the quantum world actually is before we travel back 2,000 years to ancient India.
I agree. We definitely need to understand the architecture of the wave before we can tackle the philosophy of emptiness.
Okay, let's unpack this. Starting with the quantum illusion and wave-particle duality. There is a fantastic breakdown in our sources from a physics subreddit.
Oh, that thread was great.
Right. Users were trying to explain the wave function to someone who was just completely lost, and it was a surprisingly brilliant entry point. We hear the term wave function thrown around in sci-fi movies constantly, but the actual mechanics of it are, rarely explained.
Well, the wave function is the absolute beating heart of quantum mechanics. It originates from the Schrödinger equation, developed by Erwin Schrödinger in 1925.
The famous cat guy.
Yes, the cat guy. But instead of just saying it's an equation, let's look at what it actually does. The Schrödinger equation is a differential equation.
Okay, calculus class is coming back to haunt me.
I know, stick with me. For anyone who hasn't taken calculus in a while, a differential equation doesn't just give you a static number. It relates a physical quantity to the rate at which that quantity changes.
So it's not like solving for x, where x is an apple sitting on a desk.
No, not at all. It's an equation designed to model movement and evolution over time.
Okay. And the solution you get when you solve the Schrödinger equation is the wave function itself.
Precisely.
One of the Reddit commenters used a wonderfully grounded analogy here. They said, if you want to picture a wave function, start by just imagining a standard sine wave.
Like you'd see on an oscilloscope.
Yeah, exactly. Just a shape that repeats periodically, waving up and down at a consistent rate as time moves forward. In classical physics, you use wave functions all the time to describe mundane things.
Right, like the ripples in a pond after you throw a rock.
Or the sound waves traveling from the speakers into your ears right now. But the quantum wave function operates on a totally different level of reality.
It really does, because it takes in 4 specific variables. The x, y, and z coordinates, which map out 3-dimensional space, and t, which represents time.
Okay, so a location in space at a specific time.
Right. But when you feed those 4 variables into the quantum wave function, it doesn't give you the physical location of an object. It spits out an amplitude.
And here is the massive mental hurdle. In highly simplified terms, that amplitude represents how much of a particle is at a given location at a given time.
Yes. It is entirely probabilistic. Let's contrast this with classical mechanics.
Please do.
If I throw a baseball to you, classical physics allows me to know its exact position, its mass, and its momentum at any given millisecond. I know exactly where it is and where it's going.
Yeah.
The universe is deterministic.
It's predictable.
Exactly. But in quantum mechanics, down at the level of electrons and photons, position and momentum simply do not exist as knowable, definitive quantities in that way.
Wait, they just don't exist.
Not definitively. The wave function amplitude tells you the probability of finding the particle if you decide to measure it.
Okay, so if the amplitude is very low in a specific corner of a room, it's highly unlikely you'll find the electron there.
Right, and if it's high, it's very likely.
So the particle isn't a tiny speck flying through the air, it's this vast ocean of probability. It is smeared out across space.
That's a great way to put it, smeared out.
But I have to push back on this, because my brain fundamentally rejects it every single time I look around my office.
What do you mean?
Well, I'm staring at a desk lamp right now. I don't see a smeared out ocean of statistical probabilities illuminating my keyboard. I see light. I see a definite localized phenomenon. How can it physically be a mathematical wave of maybe and a definite thing at the exact same time?
Yeah, that tension you are feeling is exactly what kept Albert Einstein awake at night. Literally.
Really? Einstein hated this.
No, he despised the probabilistic nature of it.
Right.
But to bridge the gap between the mathematics of probability and the physical light hitting your desk, we have to talk about Thomas Young's double slit experiment.
Ah, the double slit. It's heavily referenced across all our sources because it is the undeniable proof of this absurdity.
It is simultaneously the most famous and the most infuriating experiment in all of science.
Walk us through it.
So, Thomas Young initially performed it with light in 1801 to prove light was a wave. Later in the 20th century, scientists refined the experiment to fire single distinct quantum particles.
Okay, let's visualize the physical setup for everyone.
Imagine a completely solid wall. Cut into that wall are 2 narrow vertical slits sitting side by side.
Like 2 narrow doorways.
Right. And some distance behind that wall is a highly sensitive detector screen that permanently records exactly where anything hits it.
Okay, I have the mental image. Wall with 2 slits in the middle, blank canvas behind it.
Now imagine you are standing in front of the wall and you're throwing tennis balls coated in wet paint at the slits.
Sounds messy.
It is. Most of the tennis balls hit the solid wall and bounce off. But some happen to perfectly sail through the left slit and some sail through the right slit.
And when I walk around to the back screen, I'm going to see 2 neat vertical strips of paint marks, perfectly aligned with the 2 slits.
Exactly. That's the classical world, solid matter traveling in a straight line.
Okay, makes perfect sense.
But when physicists fired quantum particles, let's say individual photons of light or electrons, at those 2 slits, they did not get 2 vertical strips on the back screen.
They got a barcode.
A barcode, yes. A strange, repeating striped pattern spanning horizontally across the entire screen. An interference pattern.
Which is the undeniable signature of waves.
Right. To understand why, think of a calm pond. If you drop 2 pebbles into the water simultaneously, they both create circular ripples radiating outward.
And eventually they crash into each other.
Precisely. As those two sets of ripples expand and crash, where the high point or crest of one ripple meets the crest of another, they amplify into a bigger wave.
Right.
But where the crest of one meets the low point, the trough of another, they completely cancel each other out, leaving the water flat.
Okay, so when a wave of water hits a wall with two slits, the single wave pushes through both slits, creating two new sets of ripples on the other side that immediately interfere with each other.
Exactly, creating that complex pattern of peaks and flat zones.
So when the physicists saw that striped interference pattern on the back screen, it meant the light was moving as a wave, passing through both slits simultaneously and interfering with itself.
Yes. But here is the detail that shatters our classical intuition. As technology improved, scientists were able to turn the intensity of the light down so far that the machine was firing photons one at a single time.
Wait, one solitary particle enters the apparatus? Just one?
Just one. It travels forward. And over time, as thousands of these individual particles are fired one by one, hitting the back screen one at a time, the accumulation of dots builds up the exact same striped interference pattern.
That is just, I mean, that's insane, meaning that a single solitary particle leaves the gun, somehow spreads out into a wave of probability, travels through both the left slit and the right slit at the exact same time, interferes with itself on the other side, and then suddenly decides to land as a single dot on the screen.
Yep.
It completely defies the law of non-contradiction. A thing cannot be in two places at once.
Well, in the macroscopic world, no. But in the quantum world, before the particle hits the screen, it does not exist as a localized object.
It's a wave function.
Exactly. It exists in a state of superposition. It is a wave representing all possible paths it could take. It is everywhere it could potentially be, all at once.
But wait, it gets stranger. Because our sources dive into the observer effect, which is where this moves from weird physics into almost like philosophical horror.
Oh, the physicists running these experiments were naturally baffled by this. They wanted to know the physical mechanism. How does one particle go through two doors?
Right. You'd want to look at the doors.
Exactly. Which door does it actually go through? So they modified the experiment. They placed a small, highly sensitive detector right next to the slits to simply observe the particle as it went through.
Just to measure it and say, aha, it went left, or aha, it went right.
Yes. And the universe completely refused to give up its secrets.
I love this part.
The moment that detector was turned on, the moment the system was observed or measured to gather information about its path, the behavior of the particle fundamentally changed.
It knew it was being watched.
Essentially, yes. The interference pattern on the back screen vanished.
It collapsed.
The screen suddenly showed just two neat vertical strips, exactly like the paint-covered tennis balls.
Wow.
By simply measuring the particle at the slits, it stopped acting like a wave of infinite possibilities and collapsed into acting like a normal, solid, predictable projectile.
So the act of observation forces reality to make a choice. It forces the probability wave to collapse into a definite localized state.
Yes, this is wave-particle duality. Depending on how you interact with it, depending on the experimental context, light and matter exhibit both wave-like and particle-like properties, but never both simultaneously.
Okay, let's unpack this. Our sources highlight a fantastic quote from Einstein grappling with this exact phenomenon regarding light. He wrote, "We have two contradictory pictures of reality. Separately, neither of them fully explains the phenomena of light, but together they do."
He's conceding that you need both frameworks. The particle framework explains the localized dot on the screen. The wave framework explains the interference pattern.
Right. They are two contradictory descriptions of a single, unified, underlying reality.
This profound, dualistic nature of reality was a hard-won revelation of the 1920s. But the truly staggering part of our reading today is the realization that Eastern philosophers mapped out this exact dual framework thousands of years before the first laser was ever fired at a double slit.
Which is just wild to think about. We are transitioning from the laboratories of Europe to the monasteries of ancient India. We need to introduce Mahayana Buddhism's core ontological framework, the two truths doctrine.
Right. In Mahayana Buddhism, and specifically within the Madhyamaka philosophical school founded by the thinker Nāgārjuna around the 2nd or 3rd century CE, there is an assertion that to understand reality, you must view it through two interrelated lenses.
These are the conventional truth in Sanskrit, Samvriti Satya, and the ultimate truth, Paramartha Satya. And the way these map onto physics is just chillingly precise.
It really is.
Let's break down conventional truth first, the Buddhist equivalent of our localized particle.
Okay, so the word Samvriti carries the connotation of something that covers, conceals, or functions as a convention. Conventional truth is the everyday macroscopic world.
The world we live in.
Exactly. It is the realm of discrete, independent objects. It is the table, the chair, the car, the tree, and fundamentally, your own distinct individual self.
It's the reality governed by classical physics and linear cause and effect. I mean, if I accidentally knock my coffee mug off the desk, it falls and shatters.
Right. Gravity works, objects break.
We navigate this truth using language and conceptual thought. We draw boundaries around things so we can interact with them.
Without conventional truth, society couldn't function. We have to agree that a red traffic light is a distinct phenomena that means stop.
Obviously.
In this realm, a table is perceived as a solid, independent object with inherent properties like weight, color, and texture. This maps seamlessly to the particle state in physics. It is localized, distinct, interacting, and highly observable.
But Nāgārjuna and the Madhyamaka school warn us that stopping there is a profound mistake.
A huge mistake.
They introduce the ultimate truth, which revolves around a concept called Śūnyatā, most commonly translated into English as emptiness.
Ah, yes. Śūnyatā.
But the sources we reviewed are incredibly careful to clarify this translation, and I want to make sure we don't stumble into a Western linguistic trap here. When we hear emptiness in English, we picture a void, a black, depressing vacuum where nothing exists.
Yeah, that is the trap of nihilism. And it is a fundamental misunderstanding of Śūnyatā. Ultimate truth does not mean non-existence.
Okay, clarify that for us.
The chair is still there, your coffee mug is still there.
Yeah.
What they are empty of is inherent, independent existence.
Meaning they don't have a static, unchanging essence hiding inside them.
Exactly. Nothing exists in isolation. Everything is part of an undivided, interdependent web of causes and conditions, a concept known as dependent origination.
Let's use the table again. In conventional truth, it's just a table. But in ultimate truth, you look at the table and see that it only exists because of the wood. The wood only exists because of the tree. The tree only exists because of the soil, the rainfall, and the fusion of the sun millions of miles away.
It's all connected.
Yeah, and the table itself only took shape because of the logger, the metallurgist who forged the saw, the carpenter, and the concept of sitting invented by human biology. If you try to isolate the essential independent tableness of the table, you find absolutely nothing.
Nothing at all.
It dissolves into a temporary assemblage of infinite interactions.
And look at how perfectly this maps to the uncollapsed quantum wave function.
Oh man, you're right.
Ultimate truth represents this vast, unlocalized potentiality. It is the underlying, deeply interconnected fabric of reality before our conceptual, language-driven minds chop it up into separate, distinct objects.
Just like the wave function holds all physical potentialities before a measurement forces it to collapse into a single localized particle.
Exactly. The ultimate truth is the undivided reality before human perception collapses it into the conventional truth of separate objects.
That is mind-blowing. And the sources include a beautiful progression outlined in a text from Lhotsawa House, detailing the 3 stages of experiencing these truths. It basically tracks the evolution of human awareness.
Right. So the first stage is the baseline experience of ordinary beings, which the text calls the incorrect relative.
The incorrect relative. Sounds like my uncle at Thanksgiving.
Huh. Well, in the incorrect relative stage, a person views appearances as inherently, solidly real, and they perceive these objects with intense grasping.
So that's the trap. It's looking at the localized particle and declaring, that's the entire universe. You see the table, you think it has eternal solidity, and you become deeply attached to it.
Or, more dangerously, you view your own ego, yourself, as an independent, solid thing that must be protected at all costs.
Which naturally leads to immense suffering when the universe inevitably proves that nothing is permanent.
Exactly. Which brings us to the second stage. This is the experience of noble beings, termed the correct relative. Here, the individual realizes that appearances are deceptive.
Okay, so they see the matrix.
In a way, they know the table is fundamentally empty of inherent existence, but they still perceive it and interact with it. Crucially, though, without grasping.
So you still live your life, you still eat at the table, you still laugh with your friends, but you understand the wave nature behind the particle. You know everything is a fleeting interaction, so you don't cling to it when it inevitably changes.
Precisely. And finally, there is the absolute stage, equated with Buddhahood. The text describes this as a state where dualistic perception dissolves entirely into basic space, the rigid boundary between observer and observed, just vanishes.
What's fascinating here is a point made by the ninth Karmapa, which was cited in our reading. The two truths are not two separate zip codes.
What do you mean?
Well, it's not like the conventional world is down here on Earth, and the ultimate truth is some glowing, ethereal spirit realm floating up in the clouds.
Oh, right. There are two ways of looking at the exact same slice of space and time. The ninth Karmapa wrote, "The nature of the ground is the dual truth, free from extreme views of a permanent reality and of nihilism."
It's the middle way. It rejects the extreme view of eternalism, the idea that the table is a permanent, solid thing. But it equally rejects nihilism, the idea that nothing matters and the table doesn't exist at all.
It's the harmonious coexistence of both. Just as Einstein realized we need both the wave and the particle to understand light, Nāgārjuna realized we need both emptiness and convention to understand reality.
It is staggering to consider that contemplative mystics were outlining the precise ontological structure of quantum mechanics nearly 2 millennia before the scientific method formalized the math.
It really makes you rethink the nature of knowledge.
It does. But to truly grasp how a heavy wooden chair can actually be empty and how that ancient idea maps to modern physics, we need to look at how 21st century science has completely redefined what a thing actually is.
Because modern physics is telling us the chair isn't what we think it is.
Exactly. This takes us into the realm of relational reality and the fascinating intersection where the renowned theoretical physicist Carlo Rovelli personally encounters the ancient philosophy of Nāgārjuna.
Carlo Rovelli is a major figure in our sources. He is one of the foundational minds behind loop quantum gravity.
Exactly. Briefly.
It's an attempt to merge quantum mechanics and general relativity by proposing that space itself is quantized, made of tiny finite loops woven together.
Space is made of loops. Okay.
Yeah, but in his book Helgoland, he champions a philosophical framework known as the relational interpretation of quantum mechanics.
And the relational interpretation demands a profound shift in how we intuitively view the physical world. Rovelli argues that physical variables, the fundamental properties of matter like position, momentum, velocity, or spin, are not intrinsic characteristics of an object in itself.
Oh, right, which is why
I have to play devil's advocate here, because this sounds completely counterintuitive to anyone who has ever lived in a physical body. If I throw a baseball at 90 miles per hour, that speed feels like a definitive intrinsic characteristic of the baseball.
Sure. In the classical Newtonian framework, it is treated exactly that way. But Rovelli's relational physics argues that these variables only describe how an object interacts with something else.
Okay.
As Rovelli puts it, things have properties only relative to the other things with which they are interacting. The property isn't a badge the object wears, it is a description of the interaction itself.
Wait, so objects sitting entirely by themselves in a vacuum have no properties?
According to relational quantum mechanics, if an object is not interacting with anything, its physical properties are undefined. It has no definitive state.
Our sources include a transcript from a Google Talk Rovelli gave, and he takes this even further down to the subatomic bedrock. He states that in modern quantum field theory, the fundamental particles like quarks, which make up protons and electrons, are not the basic solid ingredients of the universe.
Right. Since the ancient Greeks, humanity has been searching for the fundamental building block, the absolute smallest indivisible speck of solid matter. But Rovelli points out that modern physics proves particles are just quantum excitations of a field.
Let's define a field really quickly for the listener. A field is essentially a fluid, continuous entity that exists everywhere in space, like a magnetic field.
Yes, exactly. And a particle is just a localized vibration or ripple within that underlying field. They are created and destroyed constantly.
Rovelli states that a particle only exists as a definitive particle when it interacts with a measuring device or another entity. In between those interactions, when it's flying through space unobserved, it opens up into a cloud of probability. It stops being a thing.
The universe is not a giant game of billiards with tiny solid balls bouncing off one another. The universe is made of events. It is a network of relationships.
And this is where Rovelli had his massive intellectual epiphany. The sources note that he was struggling for years to find a Western philosophical framework that could make sense of this bizarre relational physics.
Right, because the Western tradition is obsessed with finding an ultimate foundational substance.
Yeah, and it just wasn't compatible with what the math was showing him. And then a colleague suggested he read Nāgārjuna's masterwork, the Mulamadi Makakarika, the fundamental verses of the Middle Way.
When Rovelli read that 3rd century text, he was astounded. Nāgārjuna's central thesis is the exact philosophical mirror of relational quantum mechanics. Nāgārjuna argues that absolutely nothing exists in itself independently from something else.
The illusion of the world, what Buddhism refers to as samsara, is the mistaken belief that things possess absolute independent solidity.
Nāgārjuna's logic was relentless. He argued that all phenomena lack svabhava, a Sanskrit term meaning inherent essence. They only exist through pradecesa, or dependent co-arising.
Dependent co-arising. So a thing is only defined by its relationship to other things. Let's use Ravelli's own breakdown to make this concrete, because my earlier pushback still lingers a bit. I'm sitting in a desk chair right now. It is holding my weight. If I stub my toe on the metal leg, my toe throbs with pain. It feels like an undeniable, independent thing. How does relational physics dissect the chair?
That's a great example. Ravelli uses the chair to show how our biological perception acts as a shortcut that deceives us. Let's look at the properties of your chair. You perceive it as having a color, let's say brown. But the color brown does not exist inside the chair.
Right. Physics tells us that color is purely an interaction. It's the specific frequency of electromagnetic radiation bouncing off the atomic structure of the chair, which then interacts with the highly specific cone receptors in a human retina, which is then processed by the visual cortex.
Which is a very long chain of events.
Very long. If you turn off the light, the color is gone. If a dog looks at it, the color is different. So brown is not a property of the chair. It is an event occurring between the chair, the light, and my eyes.
Exactly. And what of the physical structure that hurt your toe? The chair is an assemblage of distinct parts. A back, a cushion, metal legs. None of those individual parts are inherently a chair.
Right.
The concept of a chair is just a useful linguistic label. We apply to a temporary arrangement of matter because of the specific function it serves in relation to human biology.
We only call it a chair because our knees bend the way they do.
That's entirely it. And if you zoom in on the metal leg, it's mostly empty space filled with atoms. Zoom in on the atoms, and they are protons and electrons. Zoom in on the electrons, and as Ravelli established, they aren't even solid entities.
Right, they are quantum excitations of a field blinking in and out of existence, only taking on the property of mass or location when they interact with the atoms in your toe.
So from top to bottom, the chair is entirely empty of inherent existence. It is just an overlapping web of relational events.
If we connect this to the bigger picture, Ravelli's relational quantum mechanics is essentially providing the mathematical proof for Nāgārjuna's concept of Śūnyatā. Physics is declaring that emptiness and interdependence are the fundamental grammar of the cosmos.
The alignment is breathtaking. The equations of the 21st century and the meditative insights of the 3rd century pointing to the exact same mechanics of reality.
It's beautiful, but as we dig deeper into the sources, a massive question arises for me. Does this interconnected wave nature apply just to the matter flying around the universe, or does it apply to the very fabric of space itself?
Oh, we are going there. That brings us to the deepest layer of the physics we are discussing today. The quantum vacuum, the Buddhist doctrine of the Trikaya, and the profound role of the observer.
Okay, let's talk about the void. When we think of a vacuum in space, we picture true emptiness, a dark, tranquil, completely silent void where absolutely nothing exists and nothing is happening.
That is the classical Newtonian view of the vacuum. But modern quantum field theory radically rethinks the void. In physics, the quantum vacuum is not empty.
None at all.
It represents the lowest possible energy state of a quantum field.
The sources describe this vacuum as an active, buzzing state teeming with fluctuating energy. And this happens because of the Heisenberg uncertainty principle.
Yes, Werner Heisenberg established that there is a fundamental limit to how precisely we can know certain pairs of physical properties simultaneously. The more precisely you know a particle's position, the less precisely you can know its momentum.
We've heard that one before.
But this principle also applies to time and energy.
Meaning that over an incredibly microscopic fraction of a second, the energy in a perfectly empty vacuum is highly uncertain. It can fluctuate wildly.
Yes, and because of Einstein's E=mc², energy can be converted into mass. These brief, massive fluctuations in energy allow for the spontaneous creation of what physicists call virtual particles.
Right. Pairs of particles and antiparticles just literally blink into existence out of the void.
They do. They borrow energy from the vacuum and then almost instantly collide and annihilate each other, returning the energy back to the vacuum before the universe's accounting system catches them.
It's like cosmic embezzlement.
Exactly. The void is practically boiling with invisible potentiality. It is a frothing sea of creation and destruction.
And this scientific understanding of the vacuum parallels a profound piece of Buddhist metaphysics outlined in a source text discussing mindful mechanisms. It's called the Trikaya Doctrine, which translates to the three bodies of a Buddha.
Let's map this out, because the structural symmetry with quantum fields is just staggering.
Okay.
The Trikaya framework illustrates three overlapping realms, or bodies of reality. The first is the Dharmakaya, which roughly translates to the truth body or reality body. In Mahayana Buddhism, this is the unmanifested, inconceivable, ultimate reality from which all things arise and to which they all return.
It is the absolute ground state, which perfectly parallels the underlying unified quantum field or the quantum vacuum. It's the silent, teeming foundation.
Exactly. The second body is the Nirmanakaya, the transformation body. This represents a transitional phase, the realm of arising forms and dynamic potential.
This maps directly to the superposition state in quantum mechanics. It is the wave function holding all the vast potentialities before a final measurement is made. It is the virtual particles blinking in and out of the vacuum, existing in a state of maybe.
Yes. And the third body is the Sambhogakaya, the manifested body or enjoyment body. This is the actualized, solid, observable world of forms that we interact with.
Which corresponds to the collapsed wave function, the localized, distinct particle that we can measure on a detector screen. The chair, the table, the broken bone on the X-ray.
It's all connected. So we have the Dharmakaya representing the underlying quantum field, the Nirmanakaya representing the probability wave of potential, and the Sambhogakaya representing the observed collapsed particle.
Both the scientific framework and the mystical framework posit that what we perceive as solid reality emerges from a deeper, undivided field of infinite potentiality.
They absolutely do.
And what actually triggers that emergence? What forces the vast wave of potential to collapse into a single point of reality? This brings us to the eerie, almost uncomfortable similarity between the act of measurement in physics and the act of perception in Buddhism.
In the double slit experiment, we saw that placing a detector next to the slits, the act of extracting information or measuring the system, caused the wave function to collapse into a definite particle, the observer effect.
Right, and in Buddhist philosophy there is an equivalent dynamic. The sources discuss how samna, the Sanskrit word for perception, and vijnana, which means consciousness or divided knowing, actively shape reality.
In Buddhist epistemology, it is the conceptualizing, categorizing mind that collapses the ultimate truth of interconnectedness, the Dharmakaya, into the conventional truth of separate objects.
So our cognitive perception acts exactly like the detector at the double slits.
It does. It forces the infinite potential of emptiness into rigid functional categories like self, other, chair, and tree so that we can survive in the world.
The Dalai Lama actually addressed this deeply in the Mind and Life dialogues, which are documented in our sources. These were incredible meetings where he brought together top theoretical physicists and elite Buddhist scholars to compare notes.
And the Dalai Lama made a really compelling philosophical argument there. He stated that quantum physics, while mathematically flawless, is an incomplete picture of reality if it lacks a philosophical framework to interpret what the math actually means for human existence.
He specifically pointed to the quantum principle of entanglement.
Right. Entanglement is when two quantum particles become linked, so that measuring the state of one instantly determines the state of its entangled partner, even if they are light years apart.
Einstein hated it. He called it spooky action at a distance.
He really did. The Dalai Lama noted that entanglement, where particles derive their properties entirely from their relationship to one another, regardless of spatial distance, mirrors Madhyamaka philosophy perfectly.
Because if a particle has no definite state until it is measured in relation to an observer, it has no inherent existence. It is exactly as Nāgārjuna described.
Let's just pause and reflect on the sheer weight of this synthesis. We have the most rigorous, mathematically predictive theories in human history, quantum mechanics and quantum field theory, pointing to the exact same mechanics of reality as contemplative traditions that relied purely on deep introspection.
It is overwhelmingly elegant. But as the host, I have to step back and ask the hard, cynical question here. Are we just getting swept away by really cool metaphors?
That is the essential, critical question we must ask, and it moves us into a crucial part of our analysis. Beware of category errors and the philosophy of science and religion.
So what does this all mean? We have to analyze the critique in our sources. Are waves-particle duality and the Buddhist two truths literally the exact same thing? Can I point to the Schrödinger equation on a chalkboard and say, look, I have mathematically proven the Buddha's enlightenment?
As the voice of rigorous academic analysis here, I must point out what the philosophical sources heavily emphasize. Directly conflating the two disciplines risks committing what philosophers call a category error.
Walk me through the architecture of a category error. Why is it philosophically dangerous to equate them completely?
Well, we need to look at the academic paper in our stack titled The Epistemic and Ontological Architecture. It explains that in strict Madhyamaka philosophy, ultimate truth is an ontological characteristic.
Ontology being the study of being.
Right. Ultimate truth is the emptiness of inherent existence itself. It is the nature of how things exist. It is not a physical substance, a physical wave, or even a physical energy field.
Oh, I see. It's a philosophical description of relationships, not a physical object you can weigh.
Correct. Meanwhile, both the wave and the particle in quantum mechanics are physical, empirical phenomena observed by science. A wave function is a mathematical abstraction used to calculate probabilities of physical events occurring in space and time.
Okay, so therefore, strictly speaking from a Buddhist philosophical perspective, both quantum waves and quantum particles belong entirely to the domain of conventional truth. Oh, wow. Let me make sure I'm conceptualizing this correctly. Even though the quantum wave is bizarre, smeared out, probabilistic, and defies classical logic, it is still a description of the physical, measurable universe.
Yes.
So saying the quantum wave is the ultimate truth of emptiness is philosophically inaccurate. The wave itself is just another conventional phenomenon that is also empty of inherent existence.
Precisely. As the 17th century Pure Land Buddhist patriarch Ui pointed out long before quantum mechanics existed, waves and particles are just two different conventional ways of describing observable phenomena.
That makes a lot of sense.
We must remember their respective domains. The Buddha's two truths are a metaphysical and ethical framework designed for achieving liberation from suffering, while quantum physics is an empirical framework designed for predicting physical observations.
Which brings us to a major stinging critique found in the sources. Evan Thompson is a philosopher of cognitive science, and his book, Why I Am Not a Buddhist, takes aim at a cultural phenomenon he calls Buddhist modernism or Buddhist exceptionalism.
Thompson is critiquing a very specific modern Western trend. There is a tendency to claim that Buddhism is superior to all other world religions because it's essentially just a highly advanced mind science that is merely waiting to be confirmed by fMRI machines and quantum physicists.
He argues that Westerners are trying to strip the messy religion out of Buddhism. They want to excise the rituals, the ethics, and the cosmology and replace it with clean, secular science.
Thompson's central argument is that Buddhism is undeniably a religion. It is fundamentally driven by a soteriological goal.
Soteriological meaning its entire purpose revolves around salvation or liberation?
Yes, liberation from the cycle of suffering. It operates on a deeply moral and ethical framework. Thompson warns that trying to use quantum mechanics to prove Buddhism reduces a profound, centuries-old ethical tradition into mere empirical data points.
It strips away the moral imperative. I mean, if we just say, hey, physics proves we are all just interconnected quantum fields, that is scientifically interesting, but it doesn't actually teach us how to treat each other.
No, it doesn't. Science is descriptive. It tells us what is. Religion and ethical philosophy are normative. They tell us what we ought to do.
The danger of Buddhist modernism is that it ignores the rich, diverse, and inherently religious context of these ancient teachings in a desperate attempt to make them palatable to a secular, scientifically minded Western audience. It hollows out the tradition.
But the sources also provide a strong counter-argument defending a secular approach. Mike Slott writes extensively defending secular Buddhism, citing the work of thinkers like Stephen Baffler, who refers to this movement as Buddhism 2.0.
And I actually lean towards Slott's defense here.
Tell me why.
Well, Slott argues that true secular Buddhism doesn't just blindly align with quantum physics to prove its intellectual superiority. Instead, it attempts to extract the pragmatic, ethical insights of the Buddha to foster human flourishing and a cosmopolitan ethics in the modern world.
That's a fair point.
It recognizes that whether reality fundamentally operates as a mathematical wave function or a discrete particle, whether loop quantum gravity is the final truth or string theory wins out, we still have to wake up every morning, navigate the conventional world, and figure out how to treat each other with compassion.
The physics is the blueprint of the house,
Mhm.
but the philosophy is how we learn to live together inside it.
Beautifully said.
This raises an important question, though, and it pulls our entire deep dive out of the theoretical clouds and down to earth. How can you, the listener, take this massive synthesis of ancient ontology and quantum physics and actually apply it to your everyday existence without getting completely lost in the intellectual weeds?
Which is the perfect entry into the final stretch of our conversation. Navigating your everyday reality using the middle way. Because all this knowledge is just trivia unless it changes how we experience life.
Knowledge must be integrated to be valuable.
I want to speak directly to you, the listener, for a moment. When I first started reading through these sources, diving into wave function collapse, the illusion of solid matter and ontological emptiness, it felt heavy.
It can be overwhelming.
It felt destabilizing, like the floor was falling out from under me. But as I read deeper, as the parallel between the physics and the philosophy clicked, I actually found an immense sense of psychological relief.
Relief from the relentless burden of maintaining an independent self.
Yes. Think about the psychological weight we carry. If both quantum mechanics and ancient Madhyamaka Buddhism are telling us that there is no solid, independent, isolated self hiding inside us, then the heavy burden of the ego is exposed as a physical and philosophical illusion.
You are not a static, rigid object that constantly has to defend its borders against the world.
No, you are a dynamic, continuous, interconnected process. You are an event, not a thing.
That realization is incredibly profound. When we internalize that we are processes intricately woven into the environment, into our communities, and into the very fields of nature around us, the exhausting pressure to maintain a permanent identity begins to dissolve.
And this brings us back to the practical application of the two truths, something often referred to as non-dual awareness.
Non-dual awareness is the psychological equivalent of wave-particle duality. Just as physicists must use the particle theory when they need to design a targeted laser, and switch to the wave theory when they need to calculate the probability of electron orbits, we must learn to fluidly shift our perspectives in daily life.
We have to live in the conventional truth. We cannot float away on a cloud of emptiness. We still have to pay our mortgages, go to our jobs, interact with our families, and fight for justice and equity in the conventional world.
Right.
But we can do all of those conventional things while maintaining an underlying awareness of the ultimate truth, the quiet knowledge that everything is impermanent, fluid, and interconnected.
The sources offer a brilliant clarifying analogy for this dual awareness. Consider a massive weather system, a storm.
Okay.
Conventionally, we classify a storm as bad if it floods our streets or ruins our crops. We classify it as good if it ends a drought and brings needed rain. Making those judgments is a conventional necessity for human survival.
Right.
But ultimately, in reality, the storm is neither good nor bad. It is merely a neutral flow of atmospheric energy, temperature, and pressure.
Recognizing that ultimate flow prevents us from becoming rigidly attached to our conventional judgments. If you get caught in a rainstorm and you are clinging to the ego-driven idea that the universe is out to get you personally, you suffer. You feel targeted.
Exactly. But if you realize it's just a complex interaction of temperatures and fields that you happen to be walking through, you still get physically wet. The conventional truth remains. But you don't suffer the psychological anguish of taking the universe personally.
The sheer elegance of both the two truths and wave-particle duality is that they both inherently reject extreme worldviews. They reject eternalism, the rigid idea that things, including our pain or our identities, last forever independently.
And they reject nihilism, the despairing idea that nothing matters and nothing exists.
They offer the middle way. The now is precious precisely because it is impermanent. The current moment is valuable because it is a fleeting interaction of quantum fields, a temporary arising of conditions that will never exist in this exact, beautiful configuration ever again.
The middle way teaches us to engage fully and passionately with the conventional world of forms, particles, and relationships, while resting deeply in the ultimate truth of emptiness, interconnectedness, and waves.
We have covered a truly staggering amount of ground today. We've traveled from the rigorous, chalk-dusted mathematics of the Schrödinger equation and the perplexing quantum laboratories of the 20th century, all the way back across time to the meditation cushions of ancient Indian mystics like Nāgārjuna.
And we have discovered that at the very bottom of reality, whether you are looking outward through a multi-billion-dollar particle accelerator or looking inward through years of deep contemplation, you do not find isolated, lonely things. You find an infinite interconnected web of relationships.
But before we let you go, there is one final, intensely provocative thought that emerges from this synthesis, something for you to mull over long after this audio ends.
If the act of observation, the observer effect in physics, is what forces the infinite wave-like possibilities of the quantum realm to collapse into a single physical reality,
Right.
and if our conceptual mind, through perception, is what collapses ultimate emptiness into the conventional world of separate objects.
Does the physical universe require our consciousness to exist at all? Or is consciousness simply the universe's way of finally looking at itself in the mirror, collapsing its own infinite potential into a reality it can actually experience?
It is a question that effortlessly bridges the gap between physics and philosophy, leaving us to wonder about our true foundational role in the cosmos.
Thank you so much for joining us on this deep dive. The next time you sit down, I encourage you to look at these seemingly solid objects around you just a little bit differently. Remember that the chair beneath you and the physical body sitting in it are just temporary, deeply beautiful interactions of a much larger infinite wave. Until next time, keep looking past the X-ray and don't be afraid to wade into the muddy waters.